um, clues to Earth's past, evidence of the distant past. Old family photos provide clues of family history. Each photo reveals something of your family's past. You can often guess the age of the photos based on their clothes, people are wearing, or the vehicles they're driving. The material the photographs are printed on also provides a clue about when the photograph was taken. Just as old photos can provide clues about a family's past, rocks can provide clues about Earth's past. Some of the most obvious clues found in rocks are the remains or traces of ancient living things. Fossils are the preserved remains of evidence. Catastrophism. Many fossils represent plants and animals that no longer live on Earth. Ideas about how these fossils formed have changed over time. Some early scientists hypothesized that great sudden disasters killed the organisms that became fossils. These scientists explain Earth's history as a series. Catastrophism is the idea that conditions and organisms on Earth change in quick violent events. The events described in catastrophism include volcanic eruptions and catastrophism and widespread flooding. Scientists eventually disagreed with catastrophism because Earth's history is full of violent events. Uniformitarianism. Most people who support catastrophism thought that Earth was only a few thousand years old. In the 17th, James Hutton rejected the idea. Hutton was a naturalist and farmer in Scotland. He noticed that the landscape on his farm could also change Earth's surface. For example, Hutton thought that erosion caused by streams could also wear down mountains. He realized that these processes would take a long time to change Earth's surface. Hutton proposed that Earth was much older than a few thousand years old. Hutton's ideas became a part of the principle of uniformitarianism. The principle of uniformitarianism states that geologic processes that occur today are similar to these that have occurred in the past. According to the view, Earth's surface is constantly being reshaped in a steady uniform manner. Today, uniformitarianism is the basic for understanding Earth's past. But scientists also know that catastrophic events do occur. Volcanic eruptions and meteorite impacts can change Earth's surface quickly. These catastrophic events can be explained by natural processes. Formation of fossils. You learn that fossils are the remains of traces and of ancient living organisms. Not all dead organisms became fossils. How are these remains preserved? Fossils from under certain conditions. Conditions from fossil formation. Most plants and animals are eaten or decay when they die. They leave no evidence that they ever lived. Think about the chances of an apple becoming a fossil. If an apple is on the ground for many months, it will decay into a soft, rotting lump. Eventually, insects and bacteria will eat it. Some conditions increase the chances of fossil formation. An organism is most likely to become a fossil if it has hard parts such as shells, teeth, or bones. The hard parts of organisms do not decay easily. An organism is also more likely to form a fossil if it's buried quickly after it dies. If layers of sand or mud buried an organism quickly, decay is shown or stopped. The fossils on the next page show how a fish might become a fossil. Fossils come in all sizes. When many people think of fossils, they think of dinosaur fossils. Many dinosaurs were large animals. Their large bones remains after they died. Not all fossils are large, even enough for you to see. Some fossils can only be seen by a microscope. These tiny fossils are called microfossils. Some microfossils are about the same size of a speck of dust. Types of preservation. Fossils are preserved in different ways. Some are trapped in ice or embedded in rock. Others actually become rock. Some fossils are not body parts. but only evidence of one living thing. Preserved remains. Sometimes the actual remains of organisms are preserved as fossils. For this to happen, an organism must be complete and closed in such material and for a long period of time. Materials such as amber, tar, ice trap, they remains and prevent air or bacteria from causing decay. Usually preserved remains are 10,000 or fewer years in age. However, insects preserved in amber can be millions of years old. Carbon films. Sometimes pressure on a buried organism is so great that all gases and liquids are released from a organism's tissues. The only thing left behind is the carbon. A carbon film is a fossilized carbon outline of an organism or part of an organism. Carbon films are usually shiny black or dark brown. Fine fish, insects, and plants' leaves are often preserved as carbon films. Mineral replacements. Copies of organisms can form from material in groundwater. Rock-forming minerals dissolve in groundwater, enter the pore spaces, or replace the tissues of fossils. The minerals soak up, fill in the spaces between the cell walls in a dead tree. The wood petrified when the CiO2 hardened. Molds. Sometimes a fossil imprint or impression is all that is left of an organism. The type of fossil is called a mold. A mold is the impression in a rock left by an organism. A mold can form when sediment hardens around a buried organism. As the organism decays over time, an impression of its shape remains in the sediment. The sediment eventually turns into rock. Casts. Sometimes after a mold forms, sediment fills the mold. The type of fossil is called a cast. A cast is a fossil copy of an organism made when a mold of the organism is filled with sediment or mineral deposits. The fossil below shows how a fossil mold and cast forms. Trace fossil. Show animals leave fossil traces of their activities. A trace fossil is preserved evidence of the ancient of an organism. The trace fossils include tracks, footprints, and nests. Scientists use trace fossils to learn about animal characteristics. For example, dinosaur tracks give clues about dinosaur's size, speed, and whether it was traveling alone or in a group. Ancient environments. Paleontologists are scientists who study fossils. Paleontologists use the principle of uniformitarianism to learn about ancient organisms and the environments in which they lived. They compare fossils of ancient organisms with organisms living today. A trilobite fossil and a horseshoe crab look alike. Horseshoe crabs they live in shallow water on the ocean, partly because trilobite fossils look like horseshoe crabs. Paleontologists infer that trilobites also lived in shallow ocean water. Shallow seas. Today, Earth's continents are mostly above sea level. Many times in the past, the sea level rose and flooded. Earth's continents, for example, the figure below shows a shallow ocean that covered much of North America about 450 million years ago. Fossils of organisms that lived in that shallow ocean help scientists reconstruct what the seafloor looked like in the past. Past climates. You might have heard people talking about global change. There is evidence that Earth's present-day climate is warming. Fossils shows that Earth's climate has warmed and cooled many times in the past. Plant fossils are good indicators of climate change. Fossils of ferns and other tropical plants indicate that much of Earth was very warm 100 million years ago. Tropical swamps and forests covered much of the land. Dinosaurs lived on Earth during this period. Millions of years later, the swamps and forests were gone. In some of these areas, coarse grasses grew. Huge sheets of ice, called glaciers, formed as the climate cooled. These ice spread over parts of North America, Europe, and Asia. Organisms that adapted into the cold climate survived. Fossils of organisms such as the woolly mammoths help scientists learn about this cold time in Earth's history. Fossils of organisms such as ferns or mammoths, help scientists learn about ancient organisms and past environments. In the following lessons, you will read how scientists use fossils and other clues, such as rock layers and radioactivity, to learn about the ages of Earth's rock. Carbon mini glossary. Carbon film, the fossilized carbon outline of an organism or a part of an organism. Cast a fossil copy of an organism made when a mold of the organism is filled with sediments or mineral deposits. Catastrophism, the idea that conditions and creatures on Earth change in quick, violent events. Fossils, the preserved remains or evidence of an ancient living thing. Mold, the impression of a rock left by an ancient organism. Paleontologists, the scientist who studies fossils. Trace fossils, the preserved evidence of an activity of the organism. Uniformitarianism, the principle that states the geologic process that occur today are similar to those that have occurred in the past.